Hey, this is Don from Padlock Technologies again with another video. Going to take a break off Cisco Secure Access. Even though I love that topic, we're going to take a break off of that and we're going to talk about Cisco ACI. So this is 1/3 of Cisco's SDN strategy. If you don't know what Cisco's SDN strategy is, or in my opinion, what it is, it's at data center, they want ACI. At the WAN, they want SD-WAN and SASE and all that good stuff. At the campus layer or the campus level, they want SDA, which is pretty much ACI for the campus network. Now, I want to be careful saying that because, again, there are two different philosophies here, or two different mindsets when you configure it. A lot of people get tripped up on ACI. They do have a light version of this called Nexus Dashboard that was formerly called DCNM. Oh, the days of DCNM. It was a good product, but it had its issues. And then you got Nexus Dashboard, which I would consider the evolution of DCNM, but it's still ACI light because there's a lot of stuff in ACI that you can do. Now you can also couple this with multi-site with the MSO, which is the multi-site orchestrator, which basically is a, let's say, a hub or another controller for the controllers. So that controller will hook into the APICs on each site, and then it does the configurations from there, and you can do the stretching of the VLANs and stuff like that. So the one thing I want to tell you about ACI is there is a special VLAN. So if you're using this VLAN, you will eventually have to migrate from it. You can change it in the settings, but when you're doing the initial setup, you kind of just next through it because it sets up all the stuff underneath it. And then you just configure the APIC management interface, but it's VLAN 4. So VLAN 4 is a special VLAN in ACI, especially when you go to try to configure multi-site, it will try to use VLAN 4 as well for some routing configurations and stuff like that. But VLAN 4 is a special VLAN. Okay. And again, this is for data centers only. So if you look at this from a design standpoint, you're going to have your spine switches and your leaf switches. Your leaf switches could technically be at the top of the rack or your Tor switches. And you can do VPC as well. Now, I showed you how to do MPBGP EVPN manually. This automates that process. And it's going to use ISIS as the IGP underlay IGP. In manual method, you can use ISIS or OSPF. So this is why I keep telling you guys, you need to learn ISIS now because it's now getting baked into so many of Cisco's products that if you don't even have a clue about how ISIS works, it's kind of hard, trying to be a network engineer or troubleshooting if you don't even understand how ISIS works at a fundamental level. So we're going to log in here. Now, this is a large topology, so there technically is 3 APICs. Cisco loves to do things in 3 because one of them is going to be a tiebreaker. So if you were to buy this, I would not do a single APIC. That is just not happening. Same thing with SDA. Don't do a single APIC. Now, the APIC for SDA is the APIC EM, which is the enterprise module, strictly for SDA. There's no EM for this. This is just normal APIC. So we log in here. I think is that. So here, when we log in, this just keeps coming up for some odd reason, but whatever. So here's the APICs. This is pretty much the status window. This is going to be an overview video. I'm not going to do everything in ACI. One, there's some new features that I'm not really up on right now because, I haven't done ACI in a little bit. I'll say my ACI, I'm probably like a month or two, maybe back behind. So maybe nothing has really changed, but I just want to check this stuff out. On top of that, this video will be 4 or 5 hours long if I actually go through every single thing in ACI. So I'm not going to do that. So my controller status, you see your controllers right here. Now this is the stuff that's in the communication between, this is the APIC cluster. The way these APICs are actually connected to ACI is they connect to the leaf switches, right? They connect to the leaf switches, and then you have out-of-bound management, which connects to maybe a switch up top. And I think I went over a design video about how APIC would look in a data center. If not, let me know if you want to see that video, and I'll show you from a blackboard, whiteboard, just drawing how, from a design standpoint, how everything works. But this are the 3 APICs that need to talk to each other, and they talk through, are they connected through the leaf switches. Basically tells you the health of your network. So over here we have tenant, fabric, virtual networking, admin stuff, which is your just, AAA settings and stuff like that. Admin to the actual fabric, stuff like that. Operations is more of your troubleshooting stuff. Hey, you want to see how data is flowing from one leaf to the other leaf. You want to make sure that everything is fine. You kind of use that operation stuff. So think about in ICE, how you have the operation tag, and you have live logs and troubleshooting and all that good stuff. Same thing in here. Apps, that one wasn't there before. Integration wasn't there before. So I'm going to check that out, see what that's all about. But all this stuff is pretty basic. So from a system standpoint, quick start always comes up. The controllers basically tells you where your controller. So if I can click controls here, this always keeps coming up here. And if I click controllers, this tells you how the controllers are connected. So you see APIC 1, 2, and 3 are connected to VTEP 1 and 2, or 101 and 102. These are leaf switches. You can tell by the L here. All right. Your system settings is your normal system settings. This is, system-wide settings that you can configure. Everything. All right. So I'm going to tell you straight out. The reason why ACI is confusing, because everything, you have to think like a programmer, right? How a programmer would think. A lot of this stuff are containerized configurations that you will ultimately attach, right? Now there's ways to attach the logical settings to the physical settings, and that's your attachable access identity profile, or AAEP for short, that connects your logical configurations to your physical configurations. But if you're going to do ACI, you need to remember you have to now kind of think a little differently, because a lot of this stuff is the commands that you would put on an interface are technically like profiles. So now you got to understand the containerization of configurations to normal interface configs. So think about it. If you're configuring SD-WAN, you got feature templates, and then you got the device template. It's literally just like that. You have the feature template, and then you ultimately tie it to a device template. Now in here though, you have the policies or interface policies, and then you tie it to an interface profile. So keep that in the back of your mind as we start doing more of these type of videos. Smart licenses, all that stuff is pretty much the same. I'm not going to go into that. Now, tenants. Now, ACI was built with multi-tenancy from the gate, right? It's just like when you do it manually, MPBGP EVPN with VXLAN as the data plane, you can do multi-tenancy. So now you remove the manual configuration so you can do it here. So you got the common tenant, the infra tenant, and the management tenant. Those come by default. The management tenant is out-of-bound management. Infra tenant is basically your underlay. Common tenant is just a common tenant amongst everything. You put things in a common tenant. But when you actually deploy this, you create your own tenant, right? So obviously I created my own tenant here, right? And then the networking pieces are going to be in here as well. Now you have your fabric. So your fabric is basically everything in your fabric. So you have your inventory, which will tell you, your topology. So if you want to look what your topology looks like, you can click topology. You'll see this is the topology here. There is spine 1, spine 2, leaf 1, leaf 2, and then your apex and all that good stuff, right? So that's a quick little visualization of what your topology looks like. When you first deploy this, you need to now discover things in the fabric. To quickly discover things, you go to fabric membership, and then you will see something like pending node registrations. So here you will find things like a node that was not registered yet. When you register the node, they pop up here in your registered nodes. So you can give it, it'll tell you, serial number, the model, what pod it's in, what the node ID is. You pick the node ID, you pick the name, and then these, of course, you're going to get the node type, but these IPs come out of a pool when you first initially set up ACI. It creates this pool to automatically add these IP addresses when you add a new leaf to the fabric or add a new spine to the fabric. It'll automatically give it one of these IPs, and you see it's a /32, so this is like a loopback. Your fabric policies are things within the fabric, so your switches and the leaf switches. So anything between there is where your fabric policies come to. So you see these interfaces here. If I were to click on here and try to do a new policy, let's see, profile. If I did a policy group here, if I wanted to, this is for a fabric port. So the fabric port is upstream, not downstream. Okay, so this is connecting to a spine switch. Same thing with the spine interfaces. Going to the leaf switches. This is not anything connecting down to a host, right? And you can create multiple policies here. As you can see, multiple policies, MACsec, global policies, interface policies, which is just like the link level, link flap, stuff like that. Transceivers that's going to be put in, switch stuff, power supply stuff. As you can see, you don't see anything in terms of interface level stuff, right? This is all fabric. So if you're going to do any fabric policies, just know it's between the leaf and the switches. And now your access policies are downstream to the host, right? So this is why a lot of people struggle with ACI, is because when you need to create something, like if you just want to turn CDP on, you can't just turn CDP on. You actually have to create an interface policy, put it to an interface group, attach it to a whole bunch of stuff. You got to attach that to now an interface selector, and you got to attach that interface selector to a switch, and then you got to pick the interface. It's a whole lot of stuff. That's why a lot of people get frustrated. But once you do it a couple times, it's not that hard. So I'll explain it from bottom up. So pools, right? So this is your VLAN pools, your multicast address, vSAN, stuff like that, VXLAN pools. Most of the time, and I'm gonna say 90% of the time, I'll even say more than that. So like 95% of the time or more, you're gonna use network centric mode. There are two modes in ACI. There's network centric and there's application centric. As many times as I deployed ACI, I have not seen one customer want to do application centric mode, because in order to do that, you need to know how your applications talk. And from a network team standpoint, very rarely does anybody, I'm not even saying network team, very rarely does anybody know how their applications talk 100%. How do you figure that out? You would probably use a tool like Cisco Secure Workloads, aka Testration, and then that will give you a map of how your applications actually talk. If you don't have that, I would stay far away from application centric mode and go strictly to network centric mode. There's still some things that you need to know about network centric mode, but it's a lot easier to transition from a network engineering standpoint. One of the things that they hate in that mode, and hopefully no one from Cisco says anything about this in the video, is the concept of VLANs. Every time I say, oh, this is just a VLAN, when I was originally training for this a long time ago back in the day, the instructor used to yell at me like, stop saying it's a VLAN. Yes, it's logically a VLAN, but we don't like using the term VLAN. So 9 times, look, I'm not in front of that instructor anymore. It's a VLAN. At the end of the day, network sector mode, it maps to a VLAN, okay? The same concept. So you have your VLAN pool. So your VLAN pool, I just created a quick pool here. This is the VLANs that can go across the port. It's not saying that all these will go over the port. It's just saying, hey, these can go over these ports. Again, I have 1 to 4094, but remember, you can't use VLAN 4 because that's used for something else. That's strictly for ACI. So stay away from VLAN 4 if you just did the default setup. Then you have your domains. So you have physical domains, then you have L3 domains, which go into your L3 out. I think I've already, yeah. So if you configured an L3 out, you have to create an L3 domain. L3 outs are basically how you get outside of the fabric. So if you look at it from an MP, BGP, EVPN manual standpoint, they call this VRF Lite. So if you were, and you have 3 options here, you can do OSPF, EIGRP, or BGP. If you do BGP, then it'll show a bunch of /32s in the upstream device. Same thing as you're doing with the manual way. If you do redistribute HMM with the route map of everything, it's just going to send all the /32s. If you do EIGRP or OSPF, you're going to get just the subnet, right? You'll get the subnet, but you won't get the /32s in it. Got to be careful with that, because depending on how you design it, you can end up causing like routing loops, because let's say you have VPC up at the top, it will see, hey, I can go to directly connect the neighbor, I can go around. There's a lot of problems that come when you use like EIGRP or OSPF. So you just got to be careful, but you can still use it. Let's see here, fiber channel stuff, that's for your storage networking. Um, Policies, this is where the rubber meets the road for most of this stuff. So your policies here, remember, this is access policy, so it's going downstream. The one thing that you got to make sure you configure is this attachable access entity profile. Why they named it that, I have no idea, but this right here is what attaches whatever logical profile that or logical configurations that you're configuring to the physical domain. If you don't have this AAEP, the ports won't work. So you got to configure at least one AAEP. And as you see, I have one here that's just now this one is connected to my L3 out and my physical domain. So you got to, if you want to talk about order operations, it's the pool, domain, AAEP. You do that. Now, once that's there, now you can start talking about interface configurations. Now, remember when I told you every interface command that you can type is technically a profile, so to speak, in ACI? You're about to see that right now. So if I click interfaces, boom, all this stuff you can configure. So 802.1x, why you do that in a data center, I don't know, but you can do it. You can turn on CDP. You can do control plane policing, data plane policing, DWDM. I would stay far away from that. Fiber channel, firewall stuff, L2 interfaces, link flaps, link levels, link flow control, LLDP, you can configure MACsec. I'm not going to go through all this. You can do port channel. You can do port security. Again, why would you do that on data center stuff? I would be careful with that. You can do storm control, which is going to stop you from, broadcast potentially hurting your network. But here's the problem. It's no layered. Well, you can do broadcast and unicast packets. So I'm not going to say what I was just going to say. So you can do all of this NetFlow configuration. So all of this stuff are individual switch commands. So what's one of these that I can pick? Link level. So link level is basically, what is the speed on the interface? But as you can see, you have to create all of this. If I was to right click on link level, create a link level policy, and then I would say, okay, here's the speed that I want to, is it a 10 gig link, 100 gig link? Is it a 400 gig link? Is it a 40 gig link? And then you would attach it to a profile later on. So you would have to configure all this stuff first and then go to a policy. You basically put this into a policy. Same thing with the switches. So if you go to the switch, you can configure all this stuff at the switch level per switch. Now, you can create VPC by doing this VPC domain command and then actually configuring the VPC here. Now, this VPC is from leaf to leaf. So you just got to be careful with this one because now you have to create port channel interfaces and not regular access interfaces. But these are all policies. And the policies don't matter. You can create a million of these things. They don't matter until you call the policy, right? So it's just like SD-WAN. Doesn't matter how many feature templates you create, unless you call it in a device template, doesn't matter. So this is where ACI can get very junky, so to speak, because someone can create, if they're trying to figure out ACI and they create 30 different policies that are not being used. Now you might use one of them and now you have 19 junk policies. That I've seen that a bunch of times. People's ACI environments are just a mess because they never went and deleted unused policies. So now that you got the policies there, and remember, this is the individual command stuff under here. Now you got to go to interface and you see this leaf interface here. And now you see this policy group. And now you got to create a policy group, right? So you have lease access port channel interfaces, VPC interfaces, PC VPC overrides, breakout ports, fiber channel ports, fiber channel port. So we're going to go to leaf access ports because I believe I created it under there. So this leaf access port is another policy that you're creating. So if I open this policy up, you can see that I turned on CDP, I turned on LLDP, I said it was a 1 gig link, and this is where you attach the AAEP to. Because if you don't attach this AAEP to this interface policy, nothing's going to work, right? Nothing's going to work, and a lot of people have messed up because they didn't attach or create an AAEP. So here's all the other things that you can attach. The same thing that I showed you with the interfaces. This is the stuff that you can technically attach if you create it, all right? So once you create that policy group, everything is good. We're not even done. We haven't even attached a port yet. Now you got to go to a profile, and now you have to create, this is your interface selector, by the way. And now you got to attach your policy to a profile. So here's the name of the profile. Here's the interface. Now in ACI, there's no E this, E that. It's just 1/this, 1/this, 1/this. So you gotta know what port you're trying to configure this on. So I said on port 1-3, I'm going to attach this policy group to 1-3. So if I open this up, you can see interface 1-3, no subs, and the policy group is PLT access ports, which matches this here, which turns on CDP, LLDP. It's a 1 gig link, and it has the AAEP that's matched to the physical domain. We're still not done yet. So after all of that has been done, now you have to go up here and actually tie it to a switch. So now we're going to go to switches here, leaf switches. I have a policy group in here, but you don't necessarily need this. You just got to go to profiles, and this is where you actually attach it to the switch. So you go to profiles, and let's look at this profile here. It says leaf port 1-3 port. We're going to go to leaf selector, which I'm picking leaf 101 and 102. And then I'm going to get the interface selector AP 1-3, which correlates with that there. So now you just see me do all that to say I'm going to run CDP and LLDP on port 1-3 on leaf 101 and 102. You have to do all of this just for that. That's why a lot of people, I like ACI, but a lot of people, when they first get to it, they're like, you got to be serious. I got to do all that to configure a port? Yes, but once you do it a couple times, it's like a walk in the park, dude. Like, it's so easy. It's a walk in the park. Now, you're still not done, because we're going to go back to the tenant so you can see the networking. This is just the interface configurations. This is not the networking side, right? So once this is all set, and now you got the port on, this activated for port 103. Now this is an active port. Normally in ACI, most of the time it's going to be a trunk port going downstream to like ESI, like VMware or whatever, Nutanix, whatever you're using, right? And when I click the virtual networking button, you'll see what I'm talking about there. But most of the time, it's a trunk port going downstream. So I just created an access port for ease of explaining. So now if we go back to tenant, when we click into Parallel Technologies, our tenant, here's where the rubber meets the road. This is the networking side of ACI. I've already built some of this stuff out. So first things first, contracts. What is a contract? So a contract is basically an enforcement mechanism of what are you going to allow in and out of an EPG or endpoint group. Now, if you're doing network-centric mode, you're really not playing around too much with this, right? You're pretty much going to do a permit any and then attach it to the EPG that says, hey, anything can go in and out of this EPG. As you get more advanced with ACI, now you can start playing around with EPGs. Like you can have a web EPG and say, okay, only thing that is allowed to go in and out of this web EPG is just, 40 and 443 traffic. You can start playing around with contracts. But if you're going to do this from scratch and you don't really know anything about ACI, I would suggest just do IP and any for now, and then work your way, do some test EPGs and stuff like that before you start jumping in and start just playing around with contracts. So a contract has a subject and it has a filter in it. So if I go down a little bit more, we go in here, we go to policies. So here's my subject, and ultimately here's my filter that says just permit IP. And if I were to look into that filter, we'll get down here, which is the filter name, the tenant, permit action. If I click down even more, you get more information, right? But this is just basically, we're permitting IP. We're not doing anything else. We're just gonna permit IP. Actually, it's IPv4, not just IP. We're gonna permit IPv4 in and out, right? Now, if you were doing IPv6, obviously you need to do that too. You have taboos, which are forbidding contracts. At least that's what, when I learned it, that's what it was, unless they change the documentation. But nobody, I'm not gonna say nobody uses taboo contracts. Most of the time it's gonna be standard contracts. All right, so that is the enforcement mechanism in ACI. Now, you can tie this in with ICE and have SGTs and all that good stuff. Again, make it simple first and then add on the advanced stuff. Don't just jump straight to advanced. The same thing I say with ICE. Get the wired and wireless set up first before you jumping all the way to TCNAC. Yeah, it might have been good in the presentation, drinking the Kool-Aid, everything is fine, and you want to go all the way to TCNAC with TrustSec and all this other enforcement stuff. If you don't even have ICE in your environment, do not go down that path, because the worst thing you could do is try to put all that stuff together and have a real bad deployment. You know, crawl, walk, run. I always suggest that. Never went wrong with that strategy. Same thing with ACI. Crawl, walk, run. So that's your contracts and ACI, right? So from a networking standpoint, this is where that instructor was really mad at me. I remember his face vividly. He was really mad at me when I kept saying that, oh, this is just a VLAN. And I understand why he's not saying that, why it's not just a VLAN, and I'll explain to you why in a minute. But if you want to make it easier on yourself, just think of everything I'm about to tell you. Once you create these configurations, I'm creating one VLAN. Okay. So from a networking standpoint, we have the L3 out, which is basically how you get out of ACI from a layer 3 perspective or router perspective. L2 out, most people never use a L2 out. Most people, this one is just way too. This is kind of unnecessary now, right? But it's still there for backwards compatibility. But in my opinion, L2 outs are pretty unnecessary. L3 outs are necessary because you want to get out from an L3 perspective. But L2 outs really doesn't make any sense to me right now, or didn't make sense to me back then, and it really doesn't make sense to me now. So I did do an L3 out here. This is the EPG. Now, when you create your L3 out, it also creates a L3 out EPG, right? And then you have a contract between your normal EPGs and then this external EPG. And that contract is still the same. Permit any. This is why I keep telling you, keep it simple. If you do permit any in network centric mode, you're going to save yourself a lot of headache, because you start toying around with contracts. You don't know what is stopping the traffic. It could be a contract on a certain EPG, it could be the routing's wrong, it could be a whole bunch of stuff. So keep it simple. So we have our logical node profiles that go to node 1 and 2, which is the leaf nodes. And then we have our interface profiles that go to, its respective leaf on node 1 and 2 ports, the respective ports on those leaves. Then we have our external EPG, which our external EPG is just basically, hey, when you can't get to anything in the fabric, as you can see, this address, this is the default gateway. If you can't get to anything in the fabric, get out through here. And this is sort of like if you're looking from a manual perspective, there's a command under the NVE interface that says membership, no, not membership, member VNI, whatever your L3 VNI associate VRF. This is technically what's that's doing, but it's doing it in a different way. From a contract perspective, you can see here's my contract, which is permit any, and you have a provider contract and a consumer contract. So a provider contract is what I am sending out. So what am I allowed to provide? Consumer contract is what am I allowed to consume? So you can have technically, and I know I'm saying technically a lot, right? So you can have something that says, I'm going to provide the web access to whatever's in this EPG, right? And then somebody else can say, I'm going to consume just web into this EPG. Now, if you mess up somewhere, now you got to look at the contract, because you might not be providing the right ports, or you might not be consuming the right ports. This is why I keep telling you, make it easy on yourself. And when you first deploy this, by doing just permit any, and we're just going to, just to make the flows to validate that our use cases are working, we just want to make sure traffic is going through each EPG. The EPG is the end all be all in terms of the enforcement, right? Contracts go on the EPG. So that's the L3 out. And this L3 out I think this is EIG. Yeah, this is EIGRP. So if I had something upstream that was doing EIGRP to to these leaf nodes, I would see two neighborships, and I would see routes. I would see subnets coming from the L3 out. Operation standpoint, again, consumer contracts and stuff like that. And see, now you can see why a lot of this can be a pain if you've never seen this before, right? Again, good product, but it has its learning curve. Your VRF is basically your routing table within the fabric. You can have multiple VRFs, and then those routing tables can't see each other, right? And then if you want to leak between VRFs, you would have to share a bridge domain with another VRF for you to be able to see it. Most of the time, if you have a tenant, they'll all be on under one VRF, and then everybody can see its routing table under that VRF. There's no, I haven't seen anybody that has one tenant and then they chop it up even more into multiple VRFs, because then when you have to leak between VRFs, it's just another pain, another thing that you have to worry about in terms of troubleshooting when routing goes wrong. And then you have your bridge domains, or what they call BDs. All right. So your bridge domains are going to be associated with the VRF. Now there's two ways you can assign a subnet: bridge domains and EPGs. If you're going to ask me, I'm going to say always assign your subnet to the bridge domain, because you can technically assign it to the EPG, but to keep everything congruent, just assign it to the bridge domain, right? Because your EPGs, you just want to enforce uh, contracts and then assign ports to those EPGs. It's another way you can assign a subnet in the EPG, but in my opinion and what I've seen, assigning it to the bridge domain is a lot better than assigning it to the EPG. I take it as, like, if you're looking at RAVPN, right? You can assign the address pool to the group policy, or you can assign it to the tunnel, right? Tunnel profile or tunnel group, sorry. Well, the GP or the group policy takes precedent over the tunnel connection or the tunnel profile. So they're just assign it to the GP, right? A lot easier. With this though, this is where you can have Anycast gateway, right? So we click on VLAN 10 from a bridge domain standpoint, and we go to policies. We have VLAN 10. That's the name I just gave it because this is going to be VLAN 10. This is the VRF it's assigned to. Again, if I have multiple VRFs, you would see a different VRF here. All this is pretty much the same. We got unknown flooding. We got unknown unicast. It's going to be a proxy. This is a regular bridge domain. It's not a fiber channel. And then from an L3 configuration standpoint, is you see this gateway here? This gateway will now exist on every leaf in the fabric, right? This is where your Anycast gateway comes in. Okay. So what does Anycast gateway allow you to do? Workload mobility. If I configure, and then if this is a data center and most of your stuff is statically configured, if I configure the default gateway is 10.1.1.254, well, this is spread across the entire fabric. So if I move it from leaf 1 to leaf 2 and the MAC address stays the same, if I move from leaf 1 to leaf 2, I don't have to re-IP anything because my default gateway travels with me, right? As long as I'm within the fabric. And then this associated L3 out means, hey, when I want to tell my upstream outside of the fabric what subnets are in the fabric, it goes to this L3 out. So if I had a EdgeRP neighbor, they would see 10.1.1.0/24 coming from the fabric switch. And that's pretty much the same configuration on every last one of these, all associated here. They're under the same VRF. So if I were to look at the routing table, I would see all these subnets here under the PLT VRF routing table. Next, application profiles. So here's where the confusing part is. And let me get back to the bridge domain real quick. This is why they didn't like the concept of saying this is a VLAN, right? Because the bridge domain can have multiple subnets to it, right? So you can think of it as if you go in interface VLAN, you have secondary IP addresses, same concept. You can do that, and you have your primary IP address. Like on here, I have 10.1.2.254. I can have another IP address and another one and another one and another one. Do I suggest you doing that? No. Especially in network-centric mode, make it easy on yourself. One subnet to one bridge domain makes it a lot easier, right? Same thing now. We're going to talk about application profile. So I'm giving that guy grace for telling me stop calling it a VLAN, but again. So you have your application profile. So here's the confusing thing about application profiles. You can have one application profile with multiple EPGs in it. Now, if we're talking about application-centric mode, the rule is create one application profile of one EPG. So if we're looking at application-centric mode, it's basically this: one bridge domain, one application profile, one EPG equals one VLAN. That's it. And you just keep doing the same thing over and over. Do you have a lot of configs that say you have hundreds of VLANs, then yes, you're going to see multiple things probably repeating itself. But it helps you from a troubleshooting standpoint isolate certain things, because if there's something going on in one EPG, you know you don't have to look at one application profile, one EPG. If you had one application profile, 100 EPGs, you may have some problems with troubleshooting. So VLAN 10, naming conventions are very important in ACI, because if you do not name stuff correct, you will configure it wrong. I am telling you right now, if you do not name things correctly in ACI, you are guaranteed to configure it wrong. Why? Because I've done it millions of times. That's why I'm a stickler for naming conventions, because you will configure something wrong if you don't name it right. So here's your application EPG. This is the end all be all, right? Everything goes into an EPG and the contract is applied there. This USEG EPG is microsegmentation. So this means you can have a microseg EPG under the same EPG. I don't have anything in here right now, but I have an EPG here, so VLAN 10. So technically I can have another EPG under VLAN 10 that would be my microseg. And then you can have contracts between that. So you can say, say if VLAN 10 was web servers, well, we can have a certain type of web server. We can say web server A, microseg EPG, and web server B, microseg microseg EPG. And then we can say those two can't talk to each other because I'm not going to apply a contract there. Like those two cannot talk to each other. So again, be careful using microsegmentation. I know that's the big thing, but that's what USEG EPGs are for. And these endpoint security groups are basically a way to tie in multiple EPGs into one group and then create policy based on the group. So if we look at the EPGs here, as you can see down here, contracts. Remember, I told you contracts get applied to the EPG because that's the end all be all, right? When you assign things. So we click on the contract here. Here's my provider contract, consumer contract. So this is basically saying I'm gonna allow everything in and everything out of this EPG. I'm not messing around with the contracts. If I were to click the EPG as a whole here at the top, click VLAN 10, and I go to operations, now you can see I've learned some things because there's some MAC addresses here, because I attached a access port, right? So that access port that I created showed you all that stuff. Configured access port, I assigned it to this EPG. That's why you see stuff here, right? And then you see the contract. Here are the contracts that are here. And then from a policy perspective, this is giving you an indicator saying what's allowed. These arrows tell you what's allowed in and what's allowed out. So in is this orange line, out is this kind of teal line, basically. Um, Ports. So if you ever wanted to assign a port to it, so here's the static port assignment that I made, and that is that, and this is your fabric policy being attached to now the networking piece. And this is another reason that fabric policy had nothing was configured until I actually statically assigned it to anything. So this is just saying, hey, here's an access port, as you can see here. Now the access port means that the traffic that you're receiving from the host is not TAC. When it's a trunk port, you can do trunk, and then you say what VLAN is this. On demand, usually we would say deploy this immediately and not on demand. So if I was to go in here and change it to immediately and then hit submit, now it's deployed immediately. But as you can see, 3 different methods. There's the trunk. Rarely do I see people use trunk native. And then there's the access. This just says, hey, this is the access port in VLAN 10. And they're going to be, you're going to plug a single host into it, right? If it was a trunk port, that means you got to switch, or you're pointing down EXI or Hyper-V or whatever downstream. Now, you're probably going to ask, how do you assign ports to the EPG? Well, you have to right click this, and then you see to say deploy static EPG port channel, VPC, or interface. So when you click that, this is where you can actually assign stuff. So you pick your nodes, whatever node you want, then you pick your interface, and then all the interfaces come up. Obviously, I did it for 3, so I'd have to select 3. If I did it for every port, because you can do a port range, then I can pick whatever port. But since I picked 3, then you assign the VLAN it's going to be in. And then is it a trunk? It is. Is it a access port? Now, here's the thing. When you're doing trunk ports, for every VLAN you now have to come in here and do the same thing over again. So let's say it was VLAN 11. I would have to go VTEP, node 101, whatever the port was, 11, 12, and say. So basically what I'm saying is VLAN 11, 10, 11, 12, 13, or 14 could be seen on this port, and I'm going to allow. That's basically all that is. It's just like a VLAN trunk allow command that you would do under an interface. And once you do that, as you can see, here's my domains that's tied to it, the physical domain. And the reason why the physical domain is tied to it, because of all the stuff I did on the interface side. So it took all that configuration, the VLAN pool, the domain, the interface policies, the interface selector, the switch configurations that it's going to, AAP, all of that. And then once you add that one port that you created, it copies all that stuff over, so you don't have to redo this. And that's how you would assign a switch port in ACI and assign it an EPG to that port. So that was a lot of work, but again, once you get used to doing it, it doesn't take that long. All right, so that was tenant, fabric, and now let's go to virtual networking. I'm gonna be real brief with this one because a lot of this used to not be here. Kubernetes, Ranger, OpenShift, OpenStack, Red Hat, Nutanix used to not be here. It used to be Microsoft Hyper-V and VMware. So what is this? This is basically called VMM domain. And what this allows you to do, and I'm going to use it from an EXI perspective because that's why I deployed it at, or that's what I'm used to configuring with EXI. What this does, it will hook into vCenter, and this will allow you to create port groups in vCenter. So this makes networking super easy for people that are doing this with EXI, right? Because now what happens is when you create an EPG and you tie it to a VMM domain, it creates a port group in ESXi. So all you have to do is when you deploy your server or whatever the workload is, you just attach it to the port group and all the networking is taken care of already. So you don't have to worry about, hey, I'm going to create this server. Now we got to get the networking involved. Nope. Once I attach it to the port group, all the ACI configuration, network configuration, BDs, VRFs, endpoint groups, all that stuff is already taken care of. So that's the beauty of using these virtual network domains. It kind of marries the two, so you never have to worry about, hey, I misconfigured something or I forgot to do something. And that's why my workload doesn't work in EXXi. Once you assign it to the port group, that's going to be pushed from ACI. Once you create the EPG that's attached to a VMM domain, you're good to go. Admin stuff is, like I said, your traditional admin stuff to get into the fabric. Operations, this is your troubleshooting stuff. So if you want to go, hey, well, here's the source, here's the destination, and it will actually show you a visual view of, how it's moving through the fabric, stuff like that. And again, apps and integration is something I haven't taken a look at because I wasn't there before. So I'll probably see what that's going on. But back to what I was saying about the VMM domain stuff. So that falls into physical domains here. All right, I remember it used to be VM domain here. Let me see if I can find this VM. Oh yeah, this is back to where I told you. So I add that domain. Here it is. So if I add that domain again, this is a new version of ACI. So you just got to be careful. Bear with me here. So if I add this domain, and then I create this domain, let's say VMM. Now you see it says VMware distributed switch, or VMware distributed switch is what it would create. And then you have your AAP, obviously. And then you have to give it the information like, okay, what is the VMM? What are the credentials? Where does it exist? And then it will hook into, you can still do your pools and stuff like that. And then this will hook into, here we go. So this will hook into your vCenter, right? Once you tell it where vCenter is, it'll hook into vCenter, right? And obviously you got to make sure that you're giving it the right username and password or none of this is going to work, right? And here you go. So you give it the credentials, you give it the vCenter IP, all that good stuff. You hit submit, and then once it hooks into vCenter, you can go back to Fabric, and then when you go to your Obviously, you need to add your pools here and all that good stuff. But when you start adding your ports, like you got your AAP, so if we go to policy, and let's say we want to create another AAP here. Am I in the right one? Like I said, this is the way. Here we go. This is the thing about ACI. You got to make sure you're in the right area. So if I go attach that, now you see this domains. You see it says VMM. If I create that VMM domain, I have to select down, and then it will, show up with the VMM domain, and then anything that I create from an EPG standpoint that's tied to that VMM domain will get pushed down into EXXI and create that port group. So that was ACI in a nutshell, right? Very good piece of technology, but it does have its learning curve. If you're going to get into this, I would definitely say this is not something for a brownfield deployment. This is something for a greenfield deployment, or do it in parallel. So you don't have to have that pressure of, hey, I might bring down my network because I configured something wrong, test it out, and then slowly start moving things over. Hopefully this video was informative. This is Don from Padlock Technologies. Thank you and have a nice day. Don't forget to share, comment, like, and subscribe.